Today's objective is to demonstrate your understanding of literal equations and word problems by completing your independent practice. So in this mini lesson, I'm just simply going to be reviewing two problems similar to some of the stuff that you're going to see on your independent practice following after. The first thing that we're going to review is literal equations, solving literal equations. So this first example says solve for b in terms of a and x. So always we want to make sure we understand what the instructions are asking us to do. So the first thing I see is that it's asking me to solve for b, which means I need to get b alone. And then it's asking me to solve for b in terms of a and x, which means that a and x have to be on the other side. So b has to be on one side, and a and x have to be on the opposite side of my equal sign. So now I'm going to look at my equation and figure out where is my b, and I see that my b is right here. So that means that I need to get everything else to the opposite side. I have to move the 7a, and I have to eventually move that -8 as well. However, as I mentioned before in class, we always leave the variable and the number next to it all the way till the end. So I'm not touching this -ab just yet. I'm going to look at what else is on the same side of b and move that to the opposite side. So in that case, I'm actually going to start with the 7a that I have right here. Now this 7a is a positive 7a. So if I want to move that positive 7a to the opposite side, I have to do the inverse operation and subtract it. Now remember that 7 and a are married to each other. They're a unit. So I cannot just simply subtract 7 or just subtract a. I'm going to subtract the whole thing together since I'm not solving for that variable. I'm only solving for b. So I subtract the 7a here, which means I'm going to subtract 7a over here as well. Now when I do that, this is going to cancel out, and I'm going to get -ab, remember to bring down its sign, is equal to, and now on the right hand side, 10x and -7a are not like terms. They come from two different families, which means I cannot add or subtract these two things, and I'm just simply going to bring down what I see. I'm going to bring down my 10x, and I'm going to bring down that -7a. So now I have -ab. And remember that my goal here is to get b by itself, which means that I still have to get rid of this -8 that I have right here. Now the operation happening between -a and b is multiplication. This is -8 times b. So if I want to get rid of that -8, I have to do the opposite or the inverse operation, and we're going to go ahead and divide by -8 on both sides. And so this is going to turn into b, or 1b, which is both the same thing, is equal to, and now remember that on the right hand side I have terms that come from multiple different families, which means I can't do anything with those three things, and I'm just simply going to bring down the big fraction. So b is equal to 10x minus 7a over -8. So remember, if you're solving a literal equation, you want to move things around so that the variable you're solving for is by itself and everything else is on the other side. Anytime you move something from one side of the equal sign to the other, you can only do that by using the inverse operation. Now the other thing that we're going to review is just one more word problem that's going to help you prepare yourself for the one that you'd have to solve in your independent practice. So here we have, Tom bought a soft drink for $3 and 7 candy bars. He spent a total of $24. How much did each candy bar cost? Now, part of my instructions or part of the work that it's asking me to show are these three things. I need to define my variable, I need to write an equation, and I need to find my solution to the equation. So first I'm going to figure out what's the variable I'm going to use and what does it represent. Now I'm going to go to the question, and it says, how much did each candy bar cost? So I'm going to put C, I'm going to use C for my variable, and then you can use any letter that you want. And I'm going to say that C is the cost of each candy bar. Now I'm going to go back into the problem and reread it and annotate it. If I can't annotate it because I'm looking at a screen, that I can take notes that can help me figure out important information that I can use to create my equation. It says Tom bought a soft drink for $3. Soft drink is just a soda. So he bought one soda for $3. So I'm going to put one soda for $3. And he also bought 7 candy bars. Okay, so we bought a total of 7 candy bars. Now I'm going to see what else is important in my problem. He said he spent a total of $24, which is also important. So in total, he spent 24 bucks. So I know that when I'm creating my equation is always going to be equal to some total. And in this case, my total is $24. The $24 that he spent in total. So the $24 includes the soda that he bought plus whatever he spent on candy bars. And that's going to give me a total of the $24. Now I already know that he spent $3 on the soda, so I know that that's a part of my equation. And I also know that he has a total of $24 that he spent. Now I know that I bought 7 candy bars, so I don't know how much he spent on all the candy bars. If each candy bar costs $1, then to figure out the price, I know I would do 7 times 1 to give me 7 bucks. If each candy bar costs $2 instead, I know I would do 7 times 2 to give me $14. If it costs $3, I would do 7 times 3 to give me $21. And I can go on and on in this pattern. However, I don't know how much each candy bar costs, so I don't know what I'm multiplying that 7 by, but I am using a variable to represent the cost of each candy bar, which is C. So instead of multiplying 7 times a number to figure out how much all the candy bars cost, I'm just simply going to multiply 7 times C, because that's what's representing us, that's what's holding the place of how much each candy bar costs. If I knew what C was equal to, then I will multiply it by 7 so that I know how much I spent on just the candy bars. So I have the $3 for the soda plus whatever I spent on the candy bars has to give me a total of $24. And so my equation can be 3 plus 7C is equal to 24. I could have also written it as 7C plus 3. It would both mean the same thing. So now that I have my equation, I can go ahead and solve it to figure out how much each candy bar actually cost. So if I have 3 plus 7C is equal to 24, I'm going to subtract 3 on both sides, and I'm going to get 7C is equal to 21. And when I divide by 7, I'm going to get C is equal to 3. So that means that each candy bar cost $3. And we're going to see if that's true. I'm going to go back into the problem, and I'm going to use the cost of $3 to see if it actually works in the sense of the problem, in the context of the problem. It says Tom bought a soft drink for $3, so those are $3 that I'm spending already, and 7 candy bars. If each candy bar costs $3, that means that I do 7 times 3, which is 21, and that has to add up to the total of $24 that he spent, which it does, which means I've done my work correctly. Make sure whatever answer you choose for your word problem makes sense in the context of the problem. When you guys do your independent practice, if it's a multiple choice question, you have different strategies you can use. You don't necessarily have to write your equation if you can solve it any other way. However, you do have to show work and you do have to show your thinking. So you can't just choose an answer for multiple choice questions. You have to show how you're arriving to your answer. Now, if it's a written response problem and it's asking you to define your variable, give an equation and a solution, then you have to do all 3 parts for that problem.